aspects we're having. So simply it is giving the advantage of, okay, so making use of the pre-processing and making use of some classifications or regression algorithms and model selection criteria, measures, all these things. Okay, so but before launching that SKLN, the second important aspect is we have to load the data or import the data set. Can someone help me, friends? What is the process to import the data set? Which are all the things we need to follow to import the data set?
We have to read the data using like a CSV file or whatever file we have.
Majority of the times we are making use of the .csv for data set, and most importantly, friends, pandas.
CSV file.
Okay, pandas, just whatever the pandas way of loading the file, just we are loading that and we are storing that particular file in our current location. Okay, you know, so just with the help of the Jupyter notebook, you can load the data. So once we get the data into our space, then what is the third aspect, friend?
Missing values, we have to do the
perform some exploratory data analysis. So this exploratory data analysis is again coming into two flavors, friends. One is describe the data and getting the information about the data. And next aspect, friends, actual missing value imputing. Missing value imputation. So now, of course, probably in today's session, we are going to cover the encoding aspects, one hot and as well as the label. Now you observe, friends, one of the important aspect here is data pre-processing or exploratory data analysis kind of thing. Whatever the data we are having, I should have at least the knowledge about how many features I'm having and what exactly the data set is, and whether the data set is containing any missing values, or do I need to perform any conversion of the data. These things should be observed by any data analyst or data engineer or data scientist, friends, because no one is going to directly launch the algorithm, because before launching the algorithm, we have to observe the data, like, you know, so discussion about the data set and based on the requirements. Okay, because as now we are dealing with the data pre-processing, I'm not giving you the requirements, but once we start with the simple linear regression or multiple linear regression, there is a problem statement, friends. Okay, within the problem statement, you can able to observe the kind of the algorithm we are going to apply on top of that particular data set. Okay, so the important thing is, so as to confirm the kind of the algorithm that we are going to apply on the given data set, we have to have a look of what exactly the data is and how we are going to perform or how we are going to activate the corresponding algorithm. Okay, after getting the describe and info hardly gives how many rows are there and how many columns are there in our data, and how many null values are there. All these things can be observed. What do you mean by describe, friends? What exactly describe does? Describe gives the minimum value,
gives the
maximum, some kind of the count. Okay, all these aspects, like, you know, 25%, 50% of the data, or summation of all the values. So it is describing the data, friends, as the name implies. So is it describing the data? Okay, just all with the help of all these things, you can decide whether I should apply the missing value imputation, because it doesn't mean that as we're having the concept of the missing value, as we're having the concept of the encoding, doesn't mean that we have to apply on your data. At times, you know, our data is fully loaded with the proper values, and you may need to use that particular data as it is without any changing. Okay, and there is one more option, friends. You know, sometimes one topic we have seen, suppose if you are referencing, if you are asking about the adding of the new feature. Suppose we are having some features x1, x2, and so on, xn. and we want to add some more feature which we feel that okay, maybe if by adding this particular feature I can able to exploit the data, I can able to better analyze my data. What is that thing called, friends?
Append, we have append and
Yeah, that thing is called as feature engineering. See, these things, all things you know, friends, actually, feature engineering, missing value imputation, encoding, all these things you will be knowing. But at the moment, they will give the scenario, that's all. So just they ask you, okay, I'm having this data set, and my data set is containing some information about a kind of the restaurant. Okay, we are having some kind of the restaurant, and the family, a number of family members, some, and thereafter whether that particular in that family whether they're having any smoking habit. Okay, and how much they have paid. Okay, and how much tip they have paid. So this is the data. I assume that now we want to generate, we want to observe whether these particular kind of the aspects, you know, so whatever the tips or whatever the paid amount we are having, what is the percentage of the tip on the entire profit or entire the payments. So definitely I have to engineer one more feature, I have to add one more feature so that I could able to observe suppose some $10,000 dollar, okay, in a particular slot, time slot from 3 to 5. So just $10,000 got paid by the members, and out of that particular $10,000, what is the tip ratio? Okay, how much tip they have got. Okay, so these kind of things may not be directly achieved with the existing features. Okay, it is all depends on the data scientist and as well as the SME and statisticians. All these members should together work, and they have to come out with a nice analogy of generating these features. Okay, friends, be cautious that only Suresh or Venkat or Lakshmi are not going to drive the entire project. Maybe 5 or 6 Suresh would be there in a team, and they defend with us and they support us, and sometimes they come up with a different strategy. It all depends, friends. Okay, we are not you are not a single driver. Okay, so many members would be there and they will give some suggestions, and to complete one scenario it takes some months together. It's not like okay, one case study and we are knowing in and out and we are going to apply. So enough support would be there and enough time would be there, and so that you can think through and you can project your ideas across, and then you can confirm what exactly you are going to apply. Okay, so that is what usage of these algorithms and feature engineering aspects and data pre-processing definitely helps you to involve in the team and showcase your efficiency. Okay, and so as to get good credentials and as well as the support from the team members. Okay, now at the moment I am referencing these particular next aspect, this exploratory data analysis may be having a various aspects, friend. It all depends upon the requirement, and once this thing is over, what is the next aspect, friends? Once the exploratory data analysis is over, then the implementation of the algorithm. So the model selection, and once this model selection is done, so then based on that particular thing you have to apply some kind of the measures of the model. So as a whole, if you see, these are all the various steps, and periodically we will be seeing some other subtopics. Okay, more or less the entire aspects are revolving around these points, friends. Okay, so importing the libraries and importing the data set and perform some kind of the data pre-processing in the context of exploratory data analysis and feature engineering. In some kind of the textbook, friend, they will separate data pre-processing and EDA and as well as the feature engineering as a separate steps. But out of my experience, I cannot see, I haven't seen any distinction between these kind of three aspects. Maybe you can say after some time, okay, this missing value imputation and as well as the encoding and feature engineering, all these are the sub aspects of this exploratory data analysis and as well as the data pre-processing. Sometimes it is always good to have the merge of these things. Otherwise, the separation. Some may feel that only understanding the data may be considering as a exploratory data analysis, and data pre-processing strictly follows missing value imputation or encoding, and it won't harm us also, friends. But ultimately, understanding of the topic and coming up with the appropriate inference is most important, rather than showcasing our technical jargon or something. Okay, all are if you are knowing and if you are having complete knowledge, and if you are making use of these kind of the aspects in a proper way, you won't be questioned, and your talent will be exploited. Okay, so that's what I'm trying to explain. And coming to the options here, if you refer, as we have seen in the earlier session, can someone talk about what we have done in the earlier session, friends, so as to handle the missing value imputation?
We have imported scikit-learn, and then we have wherever we found out the values or NAN, and then we have replaced it with the mean.
Okay. Right. Anything else? So just to see here, friends, just we have imported our data. So whatever the data, whatever the libraries we are requiring, NumPy and Pandas, and loading of the data. So this particular data loading, so just I have changed that particular name of the data for the better clarity, because data means what exactly the data. Okay, maybe you can say customer data, employee data, purchases data, whatever. So so that what I have done is, just if you are not knowing, friends, just to put the tab here, all it is showing.
You have also divided the data into Y and X.
Up to
dependent
that.
and independent variables.
Yeah. See here, purchases data. I changed that particular thing. Even I shared this particular purchases data in the drive, friends. Okay. So just if you observe this thing, and here our understanding of the data is, friends, we're having some country data with us, and we're having some age, salary of the corresponding member. And finally, whether that a person has purchased our product or not. It is not revealing everything. Only our understanding is whether the guy with these kind of the background maybe belongs to some country, age, and as well as the salary kind of aspects, whether he is able to whether he purchased that particular product or not. This much data we are having. And as a same kind of thing, we are having some few entries as nulls actually here. NaN mean, friends?
Not a number.
Not a number. Okay, so and okay, you can easily observe that in the way of Python context. If I'm saying NaN kind of thing, that belongs to null. Sometimes you maybe they are recording as null or zero. They follow different aspects, but in our example, we have seen these kind of things as NaN. Okay. Now the other point is, so before applying any kind of the missing value, or before applying any kind of the values, so we have to separate the data, friends. Now there is a simple analogy. Many at times we use it to talk about these kind of the aspects, friends. Now if you see, assume that I'm having some kind of the data with me, and this particular data follows 80% 20% rule, or else 75% 25% rule. Okay, maybe if you are remembering the days of our discussion.
Yeah, this is the training and test.
Very good. Okay, so assume that I'm having some kind of the data with me, and here I'm having all my X values, and as usual we are having this Y value, friends, here. Now if I'm saying, assume that here I'm having some 10 records, friends. I'm having 10 records. Now if I'm following 80-20 rule, that means up to 80. Okay, just if you are making use of this particular portion, and assume that this is the 80% portion of the data and this is the 20% portion of the data. And can you name these four compartment, friends? What is this compartment actually? The first one?
Extrain.
Extrain.
This is
Right.
Y train. Very good. This is friend
X test.
X test, Y test.
Y test. Okay. Now, if I am asking you why I need to separate the train and as well as the test data, what is the reason behind that?
Because the model need to understand the result. If first you need to train that particular, because the machine learning is totally on training. So you have to train the data, what you have achieved, and that data again, once it is trained, then you have to give a new data, test data to it, so that how it reacts to that new data. So you give a test data.
Okay, so if you are referencing the X-train, X-test, we are giving the clarity, and Y-train, Y-test also based on the given data, you are able to separate into 4 partitions. Okay, there is a nice function in sklearn like train test set kind of thing. It will be separated. Now the point here is, friends, let me explain in this way. In the training phase, we'll be giving the fitting of the data with X-train and as well as the Y-train. So just we are supplying those particular aspects. Whereas if you are referencing Y prediction, observe here, friends, be with me. And within this Y prediction, we are going to supply the X test rather than the Y test. Observe here. I hope you are clear with what exactly X-train, X-test, Y-train, Y-test. So moving ahead, very first phase is, as I am assuming that I am having all X-train, X-test, Y-train, Y-test. Okay. Now in the training phase, as we are all agreed upon fitting of the model with X-train and as well as the Y-train. Perfect. Now we are applying the Y prediction, and we are going to apply this particular X test. So whatever the values. Now, where do we use this Y test basically? Because in our train test split kind of the data, we are having this Y test also. Where do we use this Y test, friends? Just to think through and answer, because Y predict is not the Y test. This is not the Y test, friends.
We compare Y
We
test.
compare.
That means Y prediction is going to compare. That means the data scientist is going to compare Y prediction with the Y test. What it refers, friends, actually?
Measuring.
It refers that actually this Y predict is, what do you mean by this Y predict, friends? It is our
Output.
model output, because X test we are using. What do you mean by X test here? These 20% of the data, and we are sending our model to the testing, and we are not using this Y test actually, because Y test is already evidential data corresponding to this X test. Hope you got the point, friends. Okay, no confusion, nothing. Only the thing is, we are not using the Y test directly, but what we are doing is we are going to generate the prediction of our model. This prediction means our user base or data scientist, based on the algorithms, he is going to generate the prediction values, and these particular predictions, okay, are generated with the help of the X test actually, if you see. Okay, reason behind this is the model, however, is dependent on our training data. Model is dependent on the training data. That means X train and as well as the Y train. Once we got this particular model on top of this 80% of the data, what we are doing is we have to defend, we have to prove the strength of our model. So what we are doing, we are predicting that, and we are sending this particular X test. So however, we are having Y test as the evidential data, which is the original data or the real data from the data set. Now we are going to apply some kind of the measures between Y prediction and Y testing, so that we can come up how many of our Y predictions are exactly suited to the Y testing, or how near our Y prediction values are there towards the Y test. So if I am getting Y prediction is almost near to Y test, then what is your inference, friends? What is your inference?
Okay, kind of. Not a best one. It's okay.
Model is good because we are not pulling any mean or something, friends. Maybe you are correlating with the mean or something. I am talking about directly we are comparing the values between Y prediction and as well as the Y testing. Almost all values, maybe 85 or 90% of the values are matching to our model Y prediction with the actual values. Then definitely it is a good model. Suppose that there is a lot of errors. A lot of errors means there is only 50% of comparison is there, so that I can say the model is not well, average. So but whereas less than, okay, less than 40 or something like that, which is not even competing with mean, your model is not at all doing well. You have to do something. Maybe unnecessarily some features would be there, or else some sort of revisions would be there. All these kind of aspects you have to come across. Okay, so this is how you can refer the usage of the model and all. Okay, that is one side, friend. So why we are separating this particular training testing is this background we have to follow. And one more important thing, what is the use of this allocation?
It's an index value.
Index value. And again, friends, see, I want to pick up only the dependent values, independent values in the X. Remember, friends, X is always referencing to the
Feature.
Independent values.
Independent features. Okay, so and there are a number of ways. Maybe I can this is one of the method I can make use of separating the independent features. And once this is over, so just what we're doing, just we're making use of these particular features and dependent data. So what we're doing, friend, just we're making use of the dependent data. Always follow the rule that X is your independent, maybe X1, X2, X3. In our data science team and data engineering team, friend, generally we prefer the naming convention X as independent features and Y as a dependent label. Okay, so just to follow the same kind of the convention, so that you can easily relate your knowledge of the data science with the implementation. Okay, now what do you mean by this imputer? Actually, in the earlier session we have seen how do you refer the class and as well as the object notation, as Python is also following the object oriented kind of thing. And there is always a class notation, which is a template. And to that particular class, we are going to create some kind of the object. Okay, so here I am creating this reference. Okay, missing value kind of the reference. And what we are doing is identify the missing value. One important thing is, as I mentioned earlier, our data set always may not contain the NaN kind of thing. Maybe it is 0 or maybe some kind of null values or whichever means. But in our data set, we observed that there is a NaN present, so that we need to handle that particular presence of the NaN. So just we are making use of this NumPy and with respect to the NaN, and we have followed the convention of the strategy mean. So here, friends, what is the outcome of this particular statement finally? What is the outcome of this statement?
Wherever there is NaN, the mean will come.
Whenever there is NaN, the mean will come. That is one thing. And second thing is, just it is a logical guiding of our simple imputer. Now we have not applied anything on the data, because just we have created that logic and we have not applied. So once this particular logic is created, now I need to apply this particular logic. Where do I apply this logic, friends? There I have given the first thing is on all the rows I want to apply. Now 1, 2, 3 columns, actually 1 colon 3. What is the analogy behind this? 1 colon 3 means, friends?
1 and 2. 1
1 and 2.
1 and 2 columns are.
Yeah,
You have
1 and 2
NaN.
column, because age and salary, because our interest is not to apply this particular simple imputer on all the columns. Okay, so that what we have done, just we are making use explicitly, we have mentioned that hey, just you can apply the missing value imputing on top of these particular two columns only. It is not doing anything, friend. Just it is keeping track of all these X values and all. Now, one more important thing is, okay, we have applied this. Applied in the sense, it is keeping track of all the separations of that particular. What exactly X containing, friends, here? Can someone help me? Little bit if I'm moving. What exactly X containing? X is containing your all the features, na? Like country, age, and as well as the salary. Okay. Now, see, at the moment we are fetching this particular data. Now we want to transform the data. Our interest is not to go with NAN kind of thing. We want to replace that NAN with some kind of the changes. Okay, that change is guided by the simple imputer. What is that change, friends? That change is nothing but observe the null values in the form of the NAN, and you follow up the strategy of this particular mean, and you substitute the mean value instead of this missing value. That's it. Instead of that missing value, you substitute the mean value.
One small question here.
You can ask. Even big question also you can ask. No problem.
Yeah. The thing is, now you're saying NAN. Now, suppose your data is coming from any of the databases like SQL, Microsoft, this one, or your Oracle. You don't get NAN, you get null.
Okay.
NULL they'll put. Then how you are going to identify that here with NPy, how it is going
NumPy won't identify those things, definitely. Again, there is one more strategy. You have to follow the data engineering approach. Maybe at your level only, you have to change those particular things, because in SQL, we are having that replace function. We are having the replace function. That replace function, because see, friend, again, there are two aspects here. Okay, if you refer the concept of the data engineering and as well as the data science, you have to decide yourself which wing you want to belong. You see here, if you are belonging to the data engineering kind of thing, as our Suresh rightly said, majority of these data engineers are spending their time to observe the data from various sources, maybe from HDFS, or maybe, as our friend told, MySQL or Oracle, like these kind of the source data. These guys, a majority of these guys are they are importing the data. Okay, and there is a bridge between this data engineering team and as well as the data scientist team actually. So this data scientist clearly mentioned that null values, whatever the null values, as our friend said, because in Oracle or in MySQL, we are having different strategies to follow these nulls and all the things. Okay, where there may be there is not a direct approach of handling those things with our Python. Of course, through programming, we can do everything in Python. But if you are doing through programming, then you are not a data scientist. Again, I am referring the same point. So we are not at all the programmers or developers. We are the data scientists. We are getting the data in a ready-made fashion or in the pre-processed way. Then we are ready to apply that particular thing. We are not going to spend our whole life in converting the data or data pre-processing kind of the aspect. Only the thing is, there is a team called this particular data engineering team, and we clearly mentioned that I need null in this format. So like maybe they're having there is a facility of using Hive or HBase kind of thing, or sometimes MySQL or Oracle, anyways, which anyways. But only the thing is, they need to support us, friends. Okay, because here we are not at all interested in our data types and all, because but whereas in databases, data types are very particular. Even while applying any kind of the user defined functions or any triggers, if you are using float or if you are using integer instead of float or something, it immediately throws error, friends. They are very particular about the data types. Okay, but whereas in our analogy, we are not interested or we are not at all issuing any data type. Are you aware of these data types, friends, actually in Python? We are have I mentioned anything? Maybe in the first session of the Python, maybe we have seen like integer, float, or string kind of thing. But after that, okay, in any case, like data frame, list, we are not interested in the data type kind of thing. In the real-time scenario also, my interest is on the data only. not I don't want how I got the data and what is the data type, how much length I need to reserve. These are all not the required things, friends. So straight away, suppose Suresh is working in the data scientist team, he observed that there is a null crept into this particular data, then he can directly go and hey, this null, I cannot use this particular null. You can convert into this NAIN format. And before asking or before saying, and one important or one good news is data, whatever the data set we are going to work, that is you will be reaching to that particular data set in a fine-tuned way, friends, maybe in NAIN fashion or else some kind of categorical data kind of aspects, because at the moment it reaches to you, it would have gone to many steps of the refinement and all, and nowadays they are nicely managing directly getting the Excel sheets, and they are you might be knowing about data profiling and data synthesis. All these kind of things are there, friend, because they are not taking the chances, because majority of the data scientist work is to put their efforts in the algorithm and as well as the measures and highlighting these particular things only. And if they are spending all their time in the holding of these null values and majority of their time in understanding of the data, that is not the exact need or requirement of the data scientist. Okay, so that is how you can handle the approach of, okay, you can have a nice interaction with the data engineering team, and even before reaching that particular data set, they will give some 2 or 3 days of the times to go through the entire data set and to understand each and every feature. And in fact, you know, friends, even in your company also, you will be getting that SRS document. Hope you all are aware of that. The document clearly mentioned that what is the data set and the kind of the data, what exactly you are going to implement, and you have to spend some quite amount of the time to understand what exactly the requirement is. In the meantime, if you feel any difficulty or any misconception of understanding those kind of aspect, definitely you can raise a query, and it will be resolved by the corresponding team. Okay, so before this data scientist team, we are having the big data team, and as well as the all the database kind of the source team. And after the team, we are having the DevOps team, friends. Actually, DevOps, you know, once we have done with our model, and once we are comfortable with our model, and we want to deploy that particular model in the Amazon Web Services or any Google Cloud platforms or any ways. So in that particular case, just to provide that model, and they need to export, they need to deploy that particular model. So your task is, you know, so basically as a data scientist, you should be aware of, okay, the pre-processing techniques like missing value imputation, encoding kind of the technique, feature engineering, standardization, normalization. And one more important thing, friends, I have mentioned feature importance observation. Can someone help me to observe that? What do you mean by feature importance, friends?
Which are the features affecting, I mean,
Positively, positive contribution. And one more thing recently introduced, friends, that is recursive feature elimination. One nice topic, friends. Actually, I have seen in the recent article. Can someone help me to get what is the process of getting the feature importance, friends? How do you get that? Because we all know that all the features are not going to contribute equally. Some features are giving really uplifting the appropriate outcome, and some are not. Okay, so we are knowing that principal component analysis and some kind of the dimensional reduction techniques. Okay, dimensional reduction techniques, and some other aspects are also I have mentioned, friends. In the context
Yes.
of the algorithms, I have mentioned some of the 2 algorithms. As a byproduct of those algorithms, we are getting the feature importance plot or feature importance, some kind of the report. Decision trees, and as well as the random forest. You observe here, friends. See, always you need not go and inquire about various pre-processing techniques or various, because there is some kind of the standard. No? Definitely Suresh should not follow one kind of the notation, Venkat should not follow another kind. There is some best practices or industry standard or industry benchmarked kind of the aspects. So out of those kind of things, most of the times we bank on either PCA. Okay, we'll use either PCA or else this decision tree or random forest, because the success rate of those kind of utilization, they have researched and they have given the complete acceptance and approval, so that you can make use of those things. Okay, it doesn't mean that you have to again create user defined functions and you have to apply your all coding techniques of the Python, because this is not the place to showcase your coding talents, friends. Again, I am referencing. And if any member is very much interested in the Python coding, or if you want to be a data scientist, I am not encouraging you guys to go to the path of data engineering or data scientist, because your coding skills are secondary skills, friends. I can say, even in the interview aspects we are doing, who are today also have interviewed some of the members. Our focus is what is his contribution in terms of best practices, in terms of optimization techniques. And for everything, if he is going to write the UDF, there are performance issues, friends. See, entire linear regression and multiple regression, you can entirely develop your own, you know that entire things, because if I am giving y equal to beta naught plus beta 1 x1 and beta 2 x2, simply you can create your own mathematical implementation with the exact UDF, and you can run the code without even importing and applying the algorithms. But that is not the case, friends. Actually, we are ready-made aspects are there, and how best you are using the available things, and how customized your things so as to get the aspects in a best way. So that is only the requirement. So slightly we need to embed into these things, and definitely you will be getting that after completion of 2 or 3 algorithms. Definitely you can see that oh, this is the way we are showcasing the things. We need not worry about the much coding, or definitely don't go ahead and don't do the things in a complex way. Okay, just to showcase your understanding, and you see the possibilities or context of applying, and then you can nicely lead the aspect, friends. Okay, that is one thing. And I am about to explain about this recursive feature elimination. Okay, so what it refers is, so this is if time permit, just to go and Google it, friends. RFE is a mechanism where it is giving you, friends, some kind of it gives you the support and as well as the rank. You know, two important aspects it give. Support wise, what it does is it is giving true, false, true, false, true. And what I'm saying is RFE, I can give my data set and I can say I want only 5 elements in my corresponding day. Assume that we're having some 15 elements. Maybe I'm selecting 10 only, 10 features out of this particular 15. Like this it is giving. So true, false, up to 15 elements. And this is rank. What it is saying is 1, 3, 1, 5, 1, and so on. Is there any correlation you are seeing in support and rank, friend? Because the support and rank will be getting with the RFE underscore support and RFE underscore rank. Directly Python helps us to output these kind of things. But if I am asking you, what is the analogy behind this? Just to think through, friends, because this is the one which I am saying as a task of the day. Okay, so again, I am iterating. This recursive feature elimination helps us so as to specify the number of features I want to embed in my model. For that particular purpose, what I am doing is I am supplying the parameters as data set and as well as my required number of the features. And there are two aspects where I can make use of this particular recursive feature engineering. or recursive feature elimination, friends. Actually, this is nothing but it is recursively it is eliminating unnecessary features. Okay, it is one form of engineered feature. So we are having 15, but my request, my importance is I want to get only the 10 features which I want to make use. See, at the moment you see this particular support and rank, is there any point, is there any correlation you are observing, friend, these two? Just spend some time. I'm giving the support as true, false, true, like that. And there are two options only. One is true and one is false in case of the support. But whereas in case of the ranking, I'm having 1, 3, 1, 5, like that. Just to think through, apply your analytical knowledge. Okay, need not be the data science knowledge or something. Just you think through, friends. Observe that.
True, false. True is something that that is like we require that. False is that is not related to that we can eliminate.
No, actually, in false also, what it is giving 3 and 5. That means how much it is the degraded one. It's going on, which is not useful. Like no, the features which are not very useful, not exactly, they are not at all useful to us, that we can see in the rank.
Rank, exactly. Now the analogy, you can integrate your you can exchange your ideas now. See, as our friend Venkat told, so just he says support just is giving that which are all the out of the 15 features, as I marked only 10 features, maybe 10 features I can get as the true values. Okay, false means I need not focus on those particular values. That is the first point. Second important point is, as our friend Suresh rightly said, it is saying that, okay, if you observe, every true is containing what, friends? If you cleanly, every true is containing 1. Every true is containing 1. But whereas if I am talking about the false, there are distinct, friends, 3, 5, 9, like that. And that too, we are talking about the ranks, friends. Rank means always first is the 1 is the top rank. Na? 1 means top. And 3, 5, 9, okay, is a degraded kind of the feature. So really that feature is not contributing. Okay. And so that, see, friends, how many developments we're having earlier, before this recursive feature elimination, we have to struggle like anything. Because and even before to this PCA and dimensional reduction, because there is one standard statement, if you remember, curse of dimensionality.
You once you spoke
many at times, and even while any data scientist or machine learning engineer journey should address this particular issue, actually, curse of dimensionality. Suppose you are asked to perform the huge data, perform some kind of the analytics on huge data. Here I am not saying about the number of records, friends. Number of records, 1 lakh, 2 lakh, 3 lakh, never mind.
Features, talking about the features.
Features, maybe 15, 20, 25. Definitely our model is highly influenced by these features, friend. That's what, the separation of the data 70, 30 or 80, 20, there is a logic. But whereas at the moment you are talking about your features, definitely you should apply the logic of which feature is important and which one. Of course, definitely as a data scientist and to prove your potentiality to the team, definitely you should showcase all these kind of the techniques. And one more thing, friends, and we're having 10 days of the time, definitely 10 different algorithms we are going to talk, and definitely I'm pulling you at least 1 or 2 possibility of data pre-processing techniques, and as well as the normalization, standardization, and different kinds of measures. We may not have the chance because can someone help me, which are all the classification measures followed in the landscape of the data science? Classification measures of the classification:
configuration matrix,
confusion matrix, and then AUC ROC
curve. Sorry.
No issue.
Confusion matrix,
AUC ROC curve,
ALC ROC, and your report which gets from the Python report.
Automatically the Python classification report. Okay, those are all the common things, friends. And apart from those particular things, in case of the regression, what we are having? R square.
We have MEA, RMEA,
Yeah.
R square,
Mean
adjusted R
absolute
square.
error, mean absolute error, root mean square error, R square, adjusted R square. These are all the things, friends. And in all the 10 algorithms, okay, we are going to talk about these measures. And after 2 or 3 algorithms, you can easily say that, oh, my R square is greater, so that model is good. My RMSE is very less, so definitely my model is really doing well. So this kind of catchhold you should have, friends. Okay, because all we have seen the statistical background, probability aspects, and this is the time where you need to correlate these particular points in the coding part. Okay, so coding is not a big deal after 2 or 3 sessions of this particular coding, because this is hardly a template, friends. You may not need open your eyes also. Just you can paste that particular data set, you can change the data set, and you can apply. Suppose if any missing value or encoding technique you want, you can apply, and then you can straight away go and select the sklearn kind of algorithm. And once that algorithm is over, your measures are also standard, so that you can have a look of those particular. But definitely it takes time. At least 2 or 3 algorithms I should able to explain to you, then only we can be on track. But my strong suggestion would be, after completion of the session, before 48 hours, definitely you revise and come back and explain the things, friends. Okay, so I thought of plan today. You are ready, Suresh, with many days?
No, yeah, tomorrow I'll take tomorrow. I'll take tomorrow.
Tomorrow
I'm,
never dies. Tomorrow never
No,
dies.
no. Tomorrow I'll take it. I'm
Okay.
actually not in a position in Hyderabad. So,
Okay, no problem, it's okay. And Venkat is our lucky charm, actually, so that we'll start with Venkat, Suresh, because this is of course fourth or fifth day we are postponing. Definitely Venkat or Lakshmi, whoever, or Yogesh is there in the call. Maybe Yogesh is not there, he's still in the mode of
Not able to connect.
somewhere
yeah, one question here.
the earth, somewhere any other holiday is there, or any
No. He was not able to connect. He was
He was
trying.
not able to connect, actually. He was asking
Oh,
for
okay. Maybe
link.
In
any
fact, we
other
have
festival is there in the country, or any other country, I thought. Okay.
no, myself and Suresh were talking about that. You have mentioned that in one interview you asked the person how he has reduced the features from 200 to 50. Then Suresh was saying he did not tell us how how he has reduced to 50 months, on what basis he has. Then might we got that answer today, like.
It's
Yeah,
RFE
definitely.
is the answer.
Yeah, RFE, and as well as the PCA and dimensional reduction, maybe decision tree or random forest. Because for the decision tree and random forest, these particular dimensional reductions are the byproducts, friends, actually. So that particular byproduct, as a part of our decision tree model, we are having the feature importance plot, actually. So it gives us along with the narration of that thing. But I can say, compared with this decision tree, PCA, all these things, I have mentioned one important thing now, just now. What is that?
Curse dimensionality.
Okay, recursive recursive feature elimination. And that too with simple 1 or 2 lines of the coding, friends. See, in the data science landscape, if you are able to reduce your lines of the code, then you are number one, friends. Okay, it doesn't mean that if you are floating 50 lines of the code or 100 lines of the code, you may be considered as still a programmer or a developer, not a data scientist or something like that. With your knowledge of whatever the statistical knowledge or whatever the domain knowledge you are having, you have to observe the proper. And of course, I can give hundreds of the examples, but still one more thing would be there, na? Because if we are not talking about C or C++ programming or Python programming, we are in the field of data scientist and as well as the machine learning engineer kind of aspect. So even after studying hundreds of these kind of thing, but still some more aspects would be there. Okay, so only the thing is, I will try to manage all these most commonly used kind of things, best practices, and in our team or in our in my experience, whichever the things I have applied on top of these kind of thing, definitely I can able to embed all the things. And meantime, you can also pull some of the, that's what I'm saying. If you could able to talk something or prepare something other than these kind of thing, at least one or two, if you could able to share, so that we can have, I'm giving 10 different methods and you can add one more, at least 7 or 8 members are there, so that we will be getting 18 different kinds of the things. Okay, that's what I'm saying. So I strongly encourage you guys, you come up with your own concept. Maybe I have given the regression kind of the whatever the assumptions to Suresh and Venkat. What is that, friends? Unsupervised learning. And to Lakshmi, I have given some supervised and like that, friends. Okay, maybe even after, even I'm not giving also, you just you go through and have a look on that data pre-processing or encoding or maybe whatever, whichever you feel need more emphasis or need more methodologies. Definitely you can fetch that, and so that we can exchange the views. So in a way, the storytelling also you have to observe, and I will launch from tomorrow onwards. Just will be giving the case study and what is your way of dealing that particular thing before launching actual algorithm, because some standard meetings would be there and scrum kind of things would be there, and there are certain storytelling aspects to the client. Okay, like how we have approached and what exactly we are doing. All these are very important considerations, friends. Okay, so definitely we are going to enjoy, but only the thing is these initial implementations are a bit you have to follow up the things. Okay, so what is this fit model and what is this transform, and all these kind of things are most
One
important.
small question here.
Yeah, you can, that's what you can.
Yeah, in RFE, if you go to the notepad,
okay,
we have gone with the two things. One is a support, one is a rank. Now, when I'm going with the rank, I'm getting exact values 1, 3, 5, whatever it is. Okay, I'll consider 1 at any cost. I have to consider 1. Now, suppose the 3 is the lowest one of all other things in the false. 3 also can I consider?
Yeah, let me.
If it is okay, if that consideration is fetching my model, can I take it into the consideration, or should I not consider that?
No, actually, that is what I am coming to that point. See, your idea is, of course, 1, however, we should keep. There is no
other way. You have to
no
keep
other way.
compulsory.
And, yeah, compulsory. And one more thing is, if it is saying false and 3, what could be the reason, friends? I am about to ask that point actually. False, it is not giving a 0 or something or 9 or something. If it is common to all, that means 9 or 39 everywhere, we are not having any objection. But what it is giving, sometimes it is giving 3, sometimes it is giving 5, and then definitely some logic would be there in that. Okay, now let me correlate this point with respect to this thing. What do you mean by correlation filter? What do you mean by that, friends? Correlation filter?
It's how the other independent variable is behaving, so that
whether it should be high or low.
No, if it is high, we can eliminate that.
Now can you relate this point to this false? This is high, this is bit low. That means highly this particular feature may be correlated with another variable. And one more important point I want to ask you guys. See here, x1, x2, xn I am having, and I want to implement my model for this thing only na y. Okay, maybe it is maybe it is regression or classification. My intent is to the dependent variable. I want to compute this particular dependent on top of this independent. Now you tell me, friends, how do I identify x1 is highly correlated with x2 or x3, or x2 is highly correlated with x1, x3, and so on? What is your thought process? Because again, I am reiterating, I am always talking about the whatever the implementation, like, so just I am making use of the independent variables in the format of the x1, x2, x3, and I am making use of the dependent variable y. Simply this particular explanation is extension of this question only, friends. One important point is false is having different levels of this correlation. So one thing is you can straight away make use of this particular RFE kind of the support, and only those particular features can be considered as a X value. Hope you got the point, friends. Hope you got the point. That means your support and ranking related to independent or dependent? Friends, my internet
Independent.
connection is independent or dependent?
It's all true. It's X values, no?
All are X values only. Still,
Yeah.
anyone is having any confusion in that?
Dependent, it affects on dependent value.
It affects. Okay, that is the
But
outcome.
they are independent values.
They are all independent, definitely, friend. Because see, don't get confused. See, we are not at all talking about the outcome. We are our data pre-processing is always revolving around independent variables, or most of the times our interest is on to curate the X values only, not the Y values. Hope you got the point, friends. And similarly, this dimensionality, even I'm having 100 or 200. What is my label? How many labels I'm having in general, friends? How many labels I'm having in the data set so far? 1 or 10? Only one outcome is there. No? All maybe that patient is having cancer or not. Maybe that sales is having a hike or not. Maybe tomorrow we are going to have the session or not. All these are only having a single label. Now the point is, while curating or while performing any these kind of the dimensions, coming to this aspect, how do I estimate the correlation between these independent values? Because there we have discussed about high correlation filter, low variance filter, and
missing value.
Missing value filter, like that we're having, friends. Okay, these are all the standard statements and best practices in the industry of the machine learning and data science. These terms are very much important. Okay, now you tell me one simple point from our experience of these 35 sessions, how I can observe the correlation between X1 with other features and X2 with other features, so on. What is your thought process? Do I need to embed Y, or what is your opinion on that? Do we need to embed Y so as to establish the correlation between these values, friends?
Yeah. Why should be there actually?
See here, X1, Xn, and we are going to fit the model to find out the Y.
Why?
Okay, in the algorithm, there should be the relativity actually. But whereas, friends, the case here is we are focusing on the features actually. You know, homoscedasticity, like that feature. So that particular feature actually, my interest is whether X1 is correlated with X2, X3, X4. Whether my X2 is correlated with X1, X3, X4, likewise. Do we need really that Y support, friends, here?
No, I think no.
Never, because in the
we
model,
don't require Y support here.
yeah, in the establishment of the model only, we are going to
In the establishment of the model only we require a Y.
We require Y. But whereas in all the other cases, like if I want to identify the correlation between the features, and if I want to notify the highly correlated values, then in that particular case, there is a simple procedure, X1, X2 kind of thing. And there you need to observe these particular RFE, or else dimensional reduction, or else your PCA kind of thing, or your decision tree, or random forest. Okay, in all these kind of things, maybe the outcome might be different. In case of the RFE, you may be getting the support and as well as that rank value, and in PCA you directly get the priorities, friends. Actually, that is the easiest way, because it is simply giving first feature is 90% priority, second feature is 80% priority, third feature is 75, again fourth feature is contributing 95%, so that based on those particular percentages you can put a threshold and you can pick up the values. That is a straightforward way of doing the thing, friends. And in this particular thing, you know, with the help of the decision tree and as well as the random forest, our as a byproduct we will be getting, like it is giving some simply ranking, and out of these particular 10 features you can take the 4 or 5 features with these kind of the ranking. Straight away you can get that thing. But in case of the RFE, okay, so just it is giving the support and as well as you know, so the ranking, and there it the correlation comes into the picture, friends, again. Okay, so always high 9 or something like that, that feature is having highly correlated with the other feature kind of thing, so that we can, whether we need to support the high correlation or we need to remove that.
No, high correlation should not be there actually.
High correlation should be penalized. Okay, we should
Penalized.
avoid that particular thing.
We
And
should avoid that.
we should avoid that. Okay, and one more thing, friends, regularization is also one of the principle I am going to introduce once we are we have completed with the 2 or 3 algorithms. Because see, one of the important secret I am revealing: understanding of the algorithm, measuring of the inference, loading the data. These are all very simple, friends. Very simple. Whereas the missing value imputation, encoding, and all these dimensional reduction, these are all very important and crucial. That's what I am spending much time on these kind of the topics, because once we are through with the algorithms, nothing to discuss, friends. I am just explaining one by one, and I am showing what exactly my result of that particular algorithm, and I'm trying to associate the appropriate algorithm with the measures, and thereafter we are having the R square, RMSE kind of thing, and all those kind of the aspects done. But whereas in the scope of discussion is lies in these things only, friends. Okay, so maybe for some people they may feel okay, we are repeating the things, but it is perfectly valid and worthful, friends. Okay, because once you enter into the genre of applying the interviews and getting through with respect to the notation, you know, one question I asked in the last week, simply whether we need to perform feature engineering before a train test split or after the train test split. Scaling, I mean, feature engineering means I have to tell now which feature engineering I am following. The question is like this, friends. I'm having some data, and usually we are making use of train and test split. Now the question here is feature scaling. How many feature scaling mechanisms are there, friends? Standardization, normalization. Okay, right. Now the question I asked in the interview is, do I need to perform feature scaling first and then train test split? This is the first option. Or else after train test split, do I need to perform the feature scaling?
No. We first need to do the feature scaling, then you go with the train test.
What you told is feature scaling helps machine learning and deep learning algorithms train and converge faster. So it should be before.
Okay. So, but you know, friends, one important thing, without training and testing, how do I get the X value and as well as the Y value? You know, friends, just simply, I'm only having the data set. On top of that particular data set, I am not saying that you cannot do. Of course you can, but performance wise, which will give the good results or better results? Now you think through. Suppose I'm having the data set, I can simply apply the feature scaling, and thereafter I can give the training and test split. Okay, I can do that, no issue, no problem. I cannot say that you cannot do the feature scaling before train and test split. That's what I asked the question, whether I need to perform the feature scaling before train test split. The possibility is there. Second important thing is, after train test split, you can apply the feature scaling. The question is, performance wise, which scenario is giving the good results or best results? Okay, I observed many at times, friends. Maybe at least 2-3 projects I have intentionally computed or applied the feature scaling, and then I means our team started working on train test split. We got some kind of the predictions and some kind of observations. Whereas if you are making use of the train test split, and after that if you apply the feature scaling, the things are very clear, friends. And of course we could able to observe at least 2 to 3% of performance raise, rather following the feature scaling first and then train test split. Okay, so always remember that once you complete the train test split, and it is always better to go with the feature scaling.
Feature scaling gives you a very fair, very good idea of the data. Actually, how when you're normalizing it,
Ah,
you will have a clear idea of what the data is actually.
no, no,
Then
no.
you will do the splitting, which data you have to go for 80%, which have to go for 20%.
Yeah,
Then you apply it on the model
yeah,
training but
correct.
what you are saying is first I'll do the training and the test.
No, 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 not
Then
training, not training, train test split.
okay, train plus split.
Uh,
Then you are doing feature
scaling.
scaling on that.
Yeah, yeah. Ah, okay.
I
Yeah,
contradict on this
yeah,
actually.
yeah. Let me
But
clarify.
practically, because we have not done practically, you have done
Ah,
practically.
yeah. Maybe
That's what
that
is
gap would be
actually
there. No?
bothering
That
me.
gap would be. Yeah, definitely. No problem, Suresh. Let me explain this way. Friends, training and testing is different. Training and test split is different. Hope you got the point actually. See, train test split is different.
80-20%.
Training a model and testing a model is different.
This is the end part actually. Yeah.
That is what. See.
Actually, I was in a mode of training and testing. Yes.
No. Very good. Okay. No problem. However,
I should accept that I was wrong. Yeah.
Yeah, no, Suresh. See, simple. Your train test split and your applicability of the feature engineering all comes to the category of the data prep. That's what I said earlier in the beginning of the session. Exploratory data analysis, data pre-processing, and your feature scaling interchangeably I can use the words. If you remember, at the moment I am saying feature engineering, if you could able to connect with data pre-processing, and if I'm talking about the dimensional reduction, if you could able to reconnect with the data pre-processing, then it won't come into your mind. That means I have not yet started my training of the model. I have not yet tested the model. I'm in the processing. I am in the pre-processing. That's what you say, pre-processing. Pre-processing may be the exploratory data analysis, or maybe the feature scaling as mentioned earlier, or else missing value imputation, or else my encoding technique, whichever. Okay, whichever. So all these particular thing leads to the data pre-processing. Once I am done with perfect with my data, then only these training and testing will come into the picture. Training, you are reaching to your model training and testing, and you are done. Last step is probably the measuring only, na measurements and all these confusion matrix and all will come into the picture. So see friends, before model implementation and as well as training and testing, all the aspects you can in a high level you can consider as a data pre-processing. Actually, what do you mean by processing the data? Because something must be there, na pre-processing. If I am saying, that means before processing. Then what is that processing? What do you mean by processing, by the way? Model creation. That's what, friends. Data pre-processing before the model implementation, before construction of the model, whichever the aspects you are performing, maybe the exploratory data analysis, feature scaling, feature engineering, missing value imputation, encoding, all these things can be you can see that thing as an umbrella of data pre-processing activities. But some people won't agree, like they may be having exploratory data analysis to understand the data, maybe the visualization or describe the data, all those things. And from that point of thing, they can consider the pre-processing, because their claim is in exploratory data analysis I am not doing anything, hardly I am trying to understand the data. Once I complete that exploratory data analysis, then only I can decide whether I need to apply the missing value or whether I need to apply the encoding. Okay, their thing is also correct, because exploratory data analysis, they are separating that I am only trying to understand the data. That is a phase one. Second thing, friends, okay, now you can decide, okay, my data is having missing values. I'm having some categorical data, so that I should apply some kind of the techniques, encoding kind of the techniques. Then in that particular case, friends, I should go with the data pre-processing. Next important thing is, what do you mean by feature scaling then? Just now we have discussed. Feature scaling is nothing but units are distinct, maybe age and as well as the salary. These kind of if units are distinct or if values are distinct, what is the problem, friends? What is the problem with our model? That day I clearly mentioned. See, age always between 20 to 80. Sal maybe $10,000 to $1 lakh. Assume that. Now, as it easily, if I am giving this data to my model, then what is the problem, friends, here? What is the problem here? What model? What is the assumption of the model here? Your model.
No, it takes that salary only, and it doesn't take care of age. It says salary is of higher importance, and it work on that.
That is the point, friend. See here, see why we are very much particular about the standardization and normalization is there is some problem, friend, actually, while using the KNN kind of thing or these kind of the algorithms, if high value I'm having, model observes that, our algorithm observes that, oh, in my data set, this particular value is having high when compared. So definitely I should give priority to this particular thing. And it is creating unnecessary troubles, and it is going to interpret the appropriate data set in a different way. So as to avoid that particular thing, we are going to make use of the feature scaling. Okay, now just we are referencing that particular encoding. Can someone help me, friends, which are all the encoding techniques we need to discuss today? One is the one hot and second is the label encoder. Okay, and in the tomorrow session, probably I'm starting with simple linear regression. In that, I'm going to introduce what exactly the dummy encoding. Okay, now what exactly this one hot encoding, friends? Can someone help me? One hot encoding conceptually. So just we are placing one instead of our requirement. Okay, so first you see here our France, Spain, Germany, whether these are all, this particular country is categorical or not. What do you mean by categorical, friends?
Whichever like true or false, or
may not be always. So
it's a group type of.
If you could able to group them, if you could able to categorize them, suppose all France I can group, all Spain I can group, all Germany I can group. So it is a category, like country category. Okay. Now at the moment I am talking about yes, no, whether these things are categorical or not. Definitely. This is also a categorical kind of yes, no kind of thing. Okay. Now, if you observe this particular country data, friends, again, the same problem. If I'm suppose instead of yes, I can put 1, instead of no, I can put 0. That is perfectly all right. Your algorithm is having the understanding, oh yes, this guy is putting 1 and no, this guy is putting 0. But you see, friends, what is the problem if I'm putting France as 1, Spain as 2, Germany as 3, and our model misinterprets that Germany is having high priority in the countries, because we are giving 1, 2, 3 kind of aspects. So obviously at the moment it is saying seeing the higher values, it may misinterpret that. Then what is the solution for that? One hot encoding. You see here, friend, just I am explaining. So from the sklearn, how we have done in case of simple imputer and all these kind of thing. Next important aspect is from the same sklearn, we are having the compose functionality. Okay, so this particular compose, what it does is, it is providing the column transformer. What do you mean by transformation, friends? Changing of one value to the another value. And here, see, clearly it is mentioning in sklearn, we are having the module called pre-processing. And from that, you can import your one hot encoder. Simply, you need to have the column transformer import, and you need to have the one hot encoder. And then just what we are doing is just we are converting this particular transformed column. Okay, so just I am explaining this particular thing, friends, only this particular statement. Initially within this particular column, okay, which is the transformation we are following is the encoder. I want to encode my values, and which type of the encoding we are following, friends? One hot encoding. On which kind of the data? Okay, that means what is the index value of this particular country? What is the index value of the country? Index value 0.
Zero.
Just you observe here, friend, 0. That means my interest is I want to apply one hot encoder on 0th index. Okay, just in the format of the encoding. That is the first thing. Now, can someone help me, friends, if I am not passing through this? Passing through means reminder. Which are all the reminder aspects I am having? Apart from the country, I am having the age,
Age and salary.
salary and purchase. All these things are having. If I am not using this reminder pass through, then what is the problem? If I am not controlling, or if I am not explicitly mentioning to my column transformer, okay, you need to stop your transformation in the context of the country. If I am not using this reminder, then what is the problem, friends?
It will applicable.
By
to-
default, it goes with other also.
It goes with other also. See, simply what it does is all your 44 A's will be fixed as 0, 27 fixed as 1, 30 maybe 2, 38 maybe like different category, or because that column transform is not aware of that, friends. Simply what it does is it is going to replicate whatever the one hot encoder we are having to all these particular columns. So to avoid that particular thing, just we are mentioning that reminder equal to pass through. Okay, you need not apply, just you can use the pass through method. Okay, my interest is only on top of this particular 0, I want to apply. Whereas, okay, once this is a logic only, na transformation is a logic. Now I want to apply that particular transformation on top of that column or the entire feature. Now what exactly this X is containing, friends? From this particular thing, our X is containing this data actually. Okay, country and this
Country,
second
age
thing,
and
age,
salary.
salary, all these things. Okay, now what we are doing is we are fit and transform. Okay, there are two options, friends. In the missing value imputation, we have taken fit only. So just initially we have taken that fit and then we have transformed. Okay, just observe here, friend. First initially we have fit and then we have transformed, but there is advancement in this one hot encoder. You need not wait for the fitting and then you need not go with the transformation. Both fit and transform can be done in a single statement. Directly you can fit that particular thing and transform the same. Now what it does, friends, can someone explain up to this? What it does, our X is containing the country, age, salary and purchase.
Salary.
Not purchase, only up to salary.
No purchase, only still salary.
Only salary, because purchase is there in the Y.
Why?
Already we have split that. Okay, our X is containing only country, age,
Country,
and
age
as well
and
as
salary.
the salary. That's all. Now what we are doing, friends, we are applying this particular TC. What exactly this TC is containing?
You are applying the one hot encoder on the TC.
One hot encoder on the 0th column.
TC on the first column of that is on the country.
Country. So obviously this particular thing fit and transform. And now there is one more option, friends. See, our NumPy, all our NumPy kind of the data types are arrays, friends. Suppose if you observe this tc.fit_transform, it is not by default array. Okay, it is not the array, but our X value, if you see, simply if you are seeing this particular X value, what is the type of our X, friends? What is the type of our X?
It's an array.
Array. What do you mean by array? Long back we have seen.
Multiple series.
It's a group
Okay, just-
of data.
So some data. Okay, just we are having some
Data.
kind of the data. Now, definitely,
form.
yeah, in the form of the matrix, 2-dimensional or n-dimensional, whatever. Now, I want to convert this particular whatever the outcome into my required format, because my X is already in array. Now I am getting something. Okay, fit and transform is not definitely array. So that what we are doing, just we are typecasting, you know, na? guys? Typecasting. So just where whatever the value I'm getting, I want to change that into the integer or float kind of thing. Simply after getting this particular transformation, I want to apply this particular typecasting. So I want to convert this fit and transform outcome into the array format, and we'll be getting the final value. Now you see X, what is the difference we have seen, friends? If I am getting this particular X value here, this is my X value initially. That means France, Spain, Germany, like that. Now, if you observe this particular X value, what is your observation?
Okay, now we understood France. The first one as France. No, 1, 0, 0.
Let me do one thing. Let me copy this thing in our notepad so that we can have a comparison. Friends, sorry, I am overboarding. Okay, but we cannot stop also. No? Just 5 minutes. That's all. Bear with me. And this is the problem with me actually. Yeah. Let me share this notepad with you guys. You can easily correlate now, friends. Okay. So France.
1.0, then 0, 0.
Now you see here, France, I am pointing to whether France is present. Just at that moment, I am placing 1. Okay, this is France. So, and Spain is 0, and as well as Germany is also 0. Now, if you consider this second one, friends, can someone help me? Actually, second one is Spain. How it has taken?
It took the alphabets.
Like France, and then Germany it has taken, and then Spain. What is the third thing, friends? Actually, this is the Germany. Germany means first one is France 0, next one Germany is 1, and your Spain is 0. Okay, so that means, friends, whenever there is 1, remaining things definitely 0. Like that, it is going to perform the activity of
like
one
3
hot
places.
encoder.
Because we have 3 countries, France, Spain, and Germany. It is like identifying it as a unique code kind of thing. 1.0, 2.0. Okay.
Okay. What it is doing, it is putting all the 3 countries there.
That's all.
Okay.
What is the problem with one hot
But wherever
encoding?
the country is defining, it is putting as a 1.
Memory. When we are talking about dummy encoding, the problem with one hot encoding is it consumes a lot of memory. That's how we switch to dummy.
Very good.
Dummy.
That is the way we need to correlate. Actually, it's not. We should not stop our analogy with the current topic. If you could able to correlate, okay, we are studying something, and there is it is leading to some problems. Then what is the solution for that problem? At this moment only, instantly you should be in a position to connect with those other advancements also, friend. Then only we are. See, I am explaining something. You are perfectly understanding that thing. I am not satisfied with that, friends. You need to lead in such a way that suppose I am discussing something, there is some problem in that particular concept, maybe limitation or disadvantages. You should be in a position to tell from, I am not asking you out of the syllabus kind of aspects. Don't over travel and don't put yourself in the confusion. Only the thing is my strong insist is just you be with me, but you should be in a position to connect the dots, which are all we are already had a discussion. That's it. Okay. Now see how Venkat is saying dummy encoding, because the dummy encoding reduces the pain, friends, actually. So rather than keeping all the 3 countries, it is keeping only 2 countries. That means if 2 countries are 0, definitely it belongs to the 3rd country. Like that we'll see in the other aspect. Okay, so this is how you can correlate all these kind of the functionalities with respect to one hot encoding and as well as the dummy encoding. And in the tomorrow session, friends, what I'm giving a hint to you, and what exactly we are dealing is let me see, just to label encoder I am going to deal, and training and as well as the test split. From this point onwards, very easy. Directly we are going to talk about train test split, and then managing the standard scaler. What do you mean by this? What exactly this thing actually standard scaler? scaling, friends, actually. So if I want to convert my data into some kind of the scaling so that I can apply, I will explain all these things. Okay. So, but this may not take much time in the tomorrow session. Along with that, I am going to introduce some simple project for the simple linear regression and as well as the multiple linear regression. I will set the context. So along with me, just you can have a look, because I'll project some kind of case study, and you can come up with your ideas how we are going to implement the, and which are all the possible feature scaling, and which are all the possible data pre-processing techniques. All those things can be observed. Okay, so that's all, guys, and that's it. We have done with this encoding kind of thing. Only we have seen we could able to see only one encoding technique, that is one hot encoding. And if you are referencing the label encoder and all the test state split, tomorrow we are going to discuss. Okay, that's all, guys. Anything else?
No, Tayar. Now only I understood all.
Yeah,
When you were just citing, but could not relate. Look how it looks.
yeah. Now you see here, and again go back and relax. Just you try to see the code and whatever the topics we have discussed. Coding, nothing, friends. Nothing is there in the coding. Only your analysis, and you are picking up something, and you should correlate. Then you definitely feel happy. That's it, I can say. Okay, guys. Thank you. Tomorrow we'll meet. Bye.
Thank you.
Bye.